I'm Ben Lanz, Executive Advisor for APC Media, Power Systems Technology Magazine. We're here at IEEE Grid Edge in San Diego, California to interview thought leaders in our industry to hear their insights into the challenges that we've been facing for the last couple years and what do we need to be working on. Through these interviews, we're going to bring their insights to you, our readers. I hope you enjoy. Our next guest is Charlie Nobles with Ubiquia.
Ben, good to see you.
Vice President of Business Development, is that right?
Right, for Grid Solutions.
For Grid Solutions.
Yes.
And I had a chance to stop by your booth and get a
you did.
little bit of an education. And fascinating company. You're doing a lot with, well, what I would call the grid edge, but you might have a little different opinion about what the grid edge, and I'd like to get into that. But
Sure.
before we do, tell me about your role there and a little bit about Ubiquia.
So I head up business development,
Right.
which includes strategic international opportunities,
Okay.
which we're seeing more and more of those, as well as OEM partnerships, and then key account strategies for large utilities like you'd see here at this show. So that's, and those three hats I wear every day, sometimes several hats per day, every day. Our company is based out of Fort Lauderdale, and we really serve three markets. The smart city market, which includes smart lighting. You saw our smart lighting solution, right?
Fascinating little
Plugs into the
device
top of
that plugs into the top of the
a
street
NEMA
light.
socket on top of a street light. We have an area of smart city solutions that includes cameras and sensors and machine learning at the edge for public safety. You saw that as well.
Right.
And then of course here at this grid show, we're focused on our grid solutions that provide data and sensing of assets and conditions on the grid that really haven't been measured before.
Fascinating. Certainly a lot there, and my next question is going to lead into not only I want to hear your definition of grid edge, because here we are at the Grid Edge
Right.
IEEE conference, but what are some of the challenges that you have seen, Ubiquia has seen, and what are some of those challenges that you're solving now?
So my background includes a stint at a large investor-owned utility where I ran all the metering for 2 states. So I'm an AMI metering person by background. So I've been around the grid quite a bit, and we use the term smart grid. To be honest with you, the grid's not so smart. One of the challenges I see is over the years, we've focused so much, we mean in the utility industry, on SAIDI and SAFE and CAIDI.
Big average
we
functions.
If you think about what we've done to the grid, we've sectionalized the grid. We've broken it into smaller and smaller pieces to minimize impact when we have outages or issues.
Right, right.
And then we've put in automated switches and devices. And now you've seen the growth of behind the meter loads. Rooftop solar, electric vehicles, distributed energy resources. So we have made the grid more complicated. And to be honest with you, one of the things I think is we've made the grid more fragile. And that's a concern. And I've seen this over the last 20 plus years. In some cases, SAIDI and SAFE measures are going up the wrong way. Because now, if you don't have a high level control over what you're doing and knowledge, how do you make these automated switching operations work correctly? You get unintended consequences.
That's fascinating. I was just visiting with somebody from Schweitzer, SEL,
Yeah.
and they, the term, I don't think it's a technical term, but he called it twitchy. The grid is just, it's not as stable. There's so many more inputs and outputs and so many more interactions that we don't know the grid.
We don't know the grid. And I think, so I agree with them. I think I used the word fragile. Twitchy is another word you could use.
I've never heard of it before.
I don't disagree with that. So I think the second part is an issue as well, very problematic, is that we don't have enough monitoring of that portion of the grid.
Which portion of the grid are you referring
we talked earlier about this idea that for years substations have had significant amount of monitoring, very expensive gear, and we've moved a lot of technology to the meter with smart metering, but in between the feeder head and the meter, feeder to meter, That's where most of the assets are just exposed in the field. They're exposed
Feeder to meter, I like that
Yeah,
framework. That's
if you think about it, between the chain link fence of the substation and the meter, there's not as much smarts. There are control elements, SCADA connected control elements, but not much monitoring in between.
okay.
So we call that the visibility gap.
The visibility gap.
So you have a more complicated, segmented, sectionalized grid with more moving parts, and yet the section that is the area that's most sectionalized has the least amount of monitoring. So what we would say is we need to provide more scalable, cost-effective monitoring of assets and line conditions, both on the high voltage side and on the low voltage side, in that largest portion of the exposed grid.
It's interesting you say that. I was just interviewing someone from Arizona Public Service, and they were saying that while they see that they still have a long way to go, that is one of the areas that they feel that they've benefited the most, is investing in that area to get more visibility.
Right.
Situational awareness is the term.
Situational, and that's actually a bullet we use on our solutions, is this idea of situational awareness. What to do. You want to automate switches like capacitor banks and regulators and such. Well, based on what data? Do you have just a point data? Ironically, most of the monitoring in that portion of the grid is done at the control element. So you have a one-to-one relationship. A device that's SCADA connected that can control, like a switch, and it also can monitor at that same location.
Right.
But to be honest with you, you need more. I mean, in woodworking, what's the phrase? Measure twice, cut once.
Right. Oh yeah.
Well, we're measuring once and controlling once. That's not my own opinion. And I call this the Doble's factor. I'm making this up, of course, tongue in cheek, but I think you need that for every control device you have on the grid. You need to have 10 other areas near that where you're monitoring the grid.
Interesting. That is a real different perspective. I appreciate that, and I hadn't heard that yet.
I made that up. I mean, I came up with 10 to 1. It's just, my thought is we've got to be monitoring a lot more and feeding that data back in some type of system in real time, and then making better choices, better decisions on what to automate.
So what you're saying is that as you go out, like from a radius of measurement point, you're no longer measuring what's happening on the grid. The grid is actually influencing itself.
It's twitchy.
It's twitchy in that region, in that middle ground.
And we make it more twitchy.
Okay. Yeah, well, it's hard to have a control system unless you're actually measuring the response of the system. You have an underdamped control system, and weird things can happen.
Ironically, my master's work in engineering was in control theory.
Oh, okay.
And imagine you just turn the gain up a bit too much.
Oh yeah, you get some oscillatory
or my guitar
feedback.
amp, I turn the gain up a little bit too much, and my wife says, "Can you please turn that down?" It's twitchy.
There you go. There you go. Well, I appreciate that. So, and I appreciate that vision of trying to solve some of those challenges in that large area, which, as you said earlier, the definition of grid edge is a little bit, well, not as well defined perhaps.
It's a bit amorphous, in my opinion.
But you're saying whatever that is, I don't know what we're going to call it if we don't call it grid edge, we need to be monitoring more of that.
I agree. You know, that's, in fact, I often ask utilities when they talk about grid edge technologies, I say, well, what do you think the grid edge is? Is it the smart meter, which is really more the demarcation point for billing?
It's the grid end, or the
So I think it's not an edge. It's certainly a blunt edge, but I think it extends north of the transformer, distribution transformer, and that gets into one of our core products, is monitoring at the distribution transformer. So let's back up just a bit from the meter. The next piece of gear that a utility has north of the meter is the distribution transformer. Every meter is served by one.
Right.
And historically, there's been no monitoring of the distribution transformers. We monitor the station transformers in the substation, but we've never monitored the distribution transformer because it's not been cost effective to do so.
Sure.
So we're applying technology, scalable technology, leveraging our LTE, embedded LTE communications capabilities into devices that can attach to that core and important asset and monitor the health of that and the true condition of that asset, but also from that vantage point, you can see upstream what's feeding that transformer on the high voltage side, and you can certainly look downstream and even through and beyond the meter to see what's behind that meter.
Fascinating. And I understand that there's tens of thousands of these things out there.
Millions.
Millions. Oh, wow. So
yeah, in this country, you know, I think the average maybe for every 5 meters there's a transformer.
Well, certainly there are millions of transformers, but I'm even saying the sensors
of our device,
that can have this precise measurement, there's tens of thousands of them out there, those data points.
We've seen a huge demand for cost-effective, scalable ways to monitor in real time distribution transformers, not a data logger that you can get data back later.
Right.
Give me data now.
Right.
Because if I'm going to automate operations through a control element, I need to do that now.
Sure.
And that's kind of the low latency requirement, is a device that can monitor in real time and bring that data back in real time. And that's why we use the existing robust, secure, built out carrier networks or private LTE networks.
So you've got the sensors and connectivity through streetlights. You've got sensors on the transformers. So from what I'm calling grid edge, you've got quite a bit out there that's measuring, monitoring, providing information, real-time information. So that's more what you've solved really already. These are solutions that exist now.
The solutions
Looking forward 3 to 5 years, what is there an extension of that? Or are there other challenges that you see that your team is looking at to solve?
So there's 2 areas. One is, and I'm going to pick on EV, because EV is the great unplanned load, right? You don't call up your utility provider and say, hey, I just thought I'd let you know, I just bought an EV. You'll see increased load on the transformer. Just thought you should know. No one does that.
Yeah, right.
It's an unplanned load that can quickly overwhelm the transformer. So if you are monitoring these things, then the load curve, which used to be very monolithic, is
boring in comparison.
Changes from hour to hour. The other part is, as we put more and more devices out there bringing all this data back, and when I say a lot of real-time data, we're sampling voltages and currents and oil pressures and oil temperatures at the transformer, upstream and downstream from the transformer, 130 times a cycle. So you do the math, you sub-millisecond sampling. So what to do with all that data? So now what we're finding is the trick is data science. It's using machine learning. It's trying to process as much of that data at the edge, whatever the edge is. In our case, it would be physically at this transformer, process it at the edge to send back metadata. So instead of streaming all that data back, imagine being able to stream data back, but take some measure of that data and make observations and send this metadata back.
Right.
That you're sensing not a damage to the transformer, but you're sensing something that looks odd, a voltage variation that was unexpected, so that you can begin to feed that into utilities' operational systems. That's not an easy trick. So to be honest with you, we're hiring more data scientists
Is that right?
than engineers right now, because that's the next big thing.
Well, that's fascinating. So really looking forward is being able to, you have all the sensors out there, how do we make even better use of the sensors and not have to collect quite so much data and putting it through the system, more make intelligent decisions and just send up the pertinent information so we don't get data overload.
Well, there's some decisions you need to make at the edge, and some decisions or some trending information you can bring back and apply analytics to. One of my favorite is storm response. You know, in the utility business, you have 2 jobs: your day job and your storm job.
Okay.
And my storm job was damage assessment. So I would physically drive in and drive around an area with no power in just a small part of the grid, and I'd call in what's on the ground, what was broken, and so they could stage crews and gear. But this took a day and a half to do this. Imagine you had sensors out there that during a storm are already measuring failures, and measuring voltage irregularities, or measuring power loss, or measuring poles that have tilted. And so you're staging your crews, you're sending them down before the storm is even finished, because you already know where the damage is. You've taken a day and a half off of restoration schedules.
That's huge.
That alone, that's just one use case that pays for these sensors that are deployed broadly.
Wow. Yeah, so I've done some research in the area of the impact to GDP of utility
Major
outages.
storms.
And if you just take some broad numbers, like Florida, I think the state GDP is something like almost $4 billion a day.
Yeah.
And if you take 25% of the system out, that's still $1 billion per day. You know, that's a societal impact.
Yes.
That's not just to the utility, right? It's all of our jobs, all the tax revenue. It's
Yes,
our
it
whole
is.
society is getting impacted. And if we can shorten that, that's really gets to this not only reliable grid, but a resilient grid. We can get it back up and running.
Sure.
And a sustainable grid, because we know resiliency costs money.
Yes, it does.
But can we get it so it's sustainable, and we can actually invest in it in a way that's going to last long? and
That
have
feeds
life
into
cycle?
this other thought that I had. And by the way, you've touched on another element that I didn't mention. I mentioned this fragile grid. Well, how about a polar vortex in Texas? Today there's 8 inches of snow on the Carolina coast. My boss was supposed to be here from New Orleans. He snowed in New Orleans. So we have climate conditions, wildfires on a fragile grid. So it's not getting easier.
No,
It's
no.
getting harder.
And we all want to live in places that are more easily threatened by natural disasters.
So
right?
I think where we're getting to is, I've heard some people talk about a self-healing grid. And if you think about what it takes to be truly self-healing, that's not trivial. It's making decisions in real time in an automated sense. You can't wait for human interaction, so it's got to be the right decision. You have to have the right data.
Right.
Otherwise, you make things worse. So I think there's a lot of activity around self-healing grid by using the intelligence that we're gathering by all these sensors. At the end of the day, you have to have more monitoring of the grid to do any of this, right?
No, you make a solid argument in that regard. So, we're here at Grid Edge, and we've had a lot of great sessions. I've met a lot of people I have never met before, and a lot of old friends as well. But what brings you to Grid Edge? What's the value that you see in this Grid Edge conference?
Well, before we started this, we noted that you can't see it in the camera, but behind us is a transmission tower. So if it's Grid Edge, and there are vendors here talking about transmission technologies, dynamic loading of transmission wires all the way through and beyond the meter. But then obviously this idea that we're struggling with what the edge is changing, and it's broadening, and you see that just walking through. And so that's very affirming to me. The second thing is I see more companies focused on what to do with the data. Assuming we get the data, much more data is needed. What do we do with the data? I mean, eventually, if you look at the AI as an example, they developed, massive, large language models. That's what enabled AI. But it took trillions of data points to do that. We're going to do the same. We're going to do the same here in this space. And I see companies talking about AI. And I see them talking about data analytics and machine learning. And then you add at the edge, wherever the edge is, it's a change. It's less focused on maybe the hardware elements. It's more focused on the intelligence that you'd extract from it.
Right, right.
So I think that's a challenge for us as an industry, but I see evidence of that here at Grid Edge.
Yeah, great insight. Well, Charlie, I really appreciate visiting with you. Do you have any closing remarks?
I tell you, there's never been a more challenging but exciting time to be in the space. Look, 20, 30 years ago, if you were at a block party and people said, "What do you do for a living?" "Well, I work for the utility." "Okay, fine, I have to get another drink." Nowadays you say, "Well, I work for the utility," and people ask you, "Wow, what do you do for them?" Because and they start highlighting these issues, and they ask you about AI applied to it and this issue they've heard about here. They're more aware,
right?
And they are more aware that it's a challenging industry, and frankly, it needs talent. And I think we're getting more of that talent. So this is an exciting time to be in the space because of the challenge. So.
It certainly is, Charlie, and I've really appreciated hearing your view. Thank you for coming by. Appreciate it.
Thanks, Ben. Thanks for having me.